Okay, hi everyone. Here we are about to do practice problem number 1 from chapter 5. So hopefully you did that reading about a page and a half, 2 pages, until you got to this problem. We've learned a couple of formulas, and in practice problem number 1, we're going to need this formula here known as the probability density function for the exponential distribution. And there you see it there. Of course, it's on the document, the lecture as well. So the question says the average American takes 7 minutes to fall asleep at night, and it's implied that this is an exponential distribution. Part A, what is the value of f of 10? So we're going to use our f of x function, of course. The first thing we need to know is what is the mu? What mu do we plug in there? So we know that mu is the mean or the average, and they told us a moment ago the average American takes 7 minutes to fall asleep at night. Okay, so we know that mu is going to equal 7. So we're going to go ahead and plug that in, and now we've got a function 1 over 7 e to the negative 1/7 x. They're asking for f of 10, so we're going to plug in 10. And when we do that, I'd invite you guys to do that calculation in a calculator along with me to make sure you got the swing of it. When I rounded to 3 decimal places, I got f of 10 to be 0.034. So turns out the probability density function, f of x, it's really not that useful. So it tells us, the height of the function at 10 minutes, how tall is the function there. But as far as probabilities go, which is what we're really after, this is not all that helpful. So you will see questions that talk about the function f, the probability density function, but not a lot, and it's really not our focus. Okay, let's move on to part B, where we're going to use a probability now. So part B, it says, what percent of Americans take less than 10 minutes to fall asleep? Okay, now we get something useful. So we have the cumulative distribution function for the exponential. I've copied it right there, and I filled in our value of mu, 7 again. What percent of Americans take less than 10 minutes? When we do these probabilities, we're always going to leave the capital X. We're going to plug in a value for the little x, and in this case, it's 10. So we'll say, what are the chances that capital X is less than 10? And then that 10 also replaces this little x. That will tell us the probability, or here I'm saying the percent of Americans that fall asleep in less than 10 minutes. X is less than 10 minutes. Okay. Once we kind of get our heads wrapped around the notation for the continuous random variable, then it's just a matter of plugging in. We got our formula. Let's put that in. Again, I'll invite you, do that calculation along with me. Make sure you're getting the same thing. Here it's 0.760. I guess technically in the question I put what percent, so 76%. I'm going to leave it as a probability. Okay. Part C. It says what portion of Americans take between 5 and 10 minutes to fall asleep? And you see the graph there with the red section highlighted for just the people who fall asleep between 5 and 10 minutes. Okay, so here's how we're going to set it up, and I'm kind of giving it away. If this was class, this would be revealed a little bit slower, but that's the way it is. Instead of saying something like x is just less than 10, now we need to say x is between 5 and 10. So 5 less than x less than 10, the probability. And you think, well, I don't have a formula for this. I have a formula for a less than, right? I know how to plug that in, but this, I have no idea what to do. So here's how we're going to think of it. We're going to take the probability for x less than 10, and then we're going to subtract the probability that x is less than 5. And to help make sense of that, really what is this first one doing? It's all of the area up to 10. Then we're going to subtract all of the area up to 5. And that's going to leave us with exactly the red highlighted area that you see in the lecture. Just the area between 5 and 10 will be left. Okay. So, all right. If that makes sense, hopefully, and hopefully I'm not going too quickly here. Now we can apply our formula twice. For x less than 10, I've got my cumulative distribution function plugging in 10. For x less than 5, same thing, plugging in 5. I'm going to put big parentheses around them both because I'm going to subtract. If I do this calculation, well, I already did that a moment ago. It was that number there, 0.760. If I do this calculation, again, please follow along with me, 0.510. So my final answer is 0.250, the probability that a randomly chosen American falls asleep on average between 5 and 10 minutes, 0.250, 1/4 of the population, according to our data. And there's part C. Let's move along. Obviously, as you're watching these, I know you know this already, but pause anytime, right? Go back, think about it, write down a question. Here's part D. I'm trying not to go too quickly. It's difficult sometimes because you're not, sitting there in front of me. I'm just talking to myself here, but okay. Part D. What proportion of Americans take over 20 minutes to fall asleep? Now we're flipping it around. What are the chances that capital X is greater than 20, more than 20? Okay, here's the idea. We don't have a formula for that. We only have a formula for a less than. So what are we going to do? Think of this, it says in the problem, take over 20 minutes, but it could have been phrased as at least 20 minutes. What are the chances that a randomly chosen person takes at least 20 minutes? 20 minutes or more. And that word at least, hopefully that strikes you. We're going to use the complement here. Here's how we're going to do it. We're going to think of it this way. The probability that x is greater than 20, we're going to take the probability that x is less than 20 and subtract that from 1. If we can find this probability, subtract it from 1 or 100%, then we'll have the other, the other side of the coin, if you will, where x is greater than 20. Okay, hopefully you can follow that makes sense. Now we can do something. We know the probability here. We know a formula, so we'll take our same exponential formula with mu is 7. Now we'll plug in 20, and we'll be sure to do 1 minus that whole thing. It's kind of odd that there are two 1 minuses with just the nature of our formula for the probability in this one. If I calculate that number only, I get this 0.943. And so my final answer, 0.057, when I perform the complement doing the 1 minus. That is the probability that a randomly chosen person takes at least 20 minutes, more than 20 minutes on average, to fall asleep at night. Okay, we've got one last part. Part E. And I'll read it off the lecture. What is the 50th percentile of minutes to fall asleep? Okay, in part E, they're switching it up on us. They're giving us the answer. They're telling us 50%, the 50th percentile. But what's the minutes? What will be the x in this particular case? What x is going to produce 0.5 probability, 50%? So we're going to say, well, we're going to have to solve for x. We're going to have to set this up. Okay, well, you get it. It's on the screen. So we're going to take our formula for the probability, 1 minus e to the negative 1/7 x, set that equal to 0.5, and go about solving. And you can see, okay, here's where eventually we've got the e. Eventually we're going to use a natural log to cancel the e. And that's absolutely right. But we got to get ourselves in a position to do that first. So here's what we'll do. We can subtract the 1 from both sides, right? We'll take the negative of both sides. Now, once we have our e by itself, and I'm sorry it's a little fuzzy on the screen, that's a 1/7. Once we have the e by itself, and there's no negative or anything, now we can take the natural log of both sides. The natural log and the e cancel, and we arrive at this, negative 1/7 x equals the natural log of 0.5. Let's multiply by negative 7 to cancel that over here. And putting that last line there into a calculator, again, I invite you to do it at the same time that I'm kind of showing the answers, or maybe pause or something. The answer to this one, 4.852. And if you thought of the units, I didn't write them in, but that's minutes. The 50th percentile is 4.852 minutes. So that means 50% of people fall asleep in less time than this, and 50% of people fall asleep in more time than this. That's the idea. As far as this question goes, you might stop right there. If I can make it a bit more clear, I wrote out in words what that means. 50%, since we're dealing with a percentile, the 50th percentile is always a less than. 50% of Americans fall asleep in less than 4.852 minutes on average. So our 50th percentile, 50% of the population is this number or less. So there you go. There's really the meaning of what we're finding in part E. Okay, we'll stop the video here. Next video, keep reading. We'll do practice problem number 2.